Hello, chemistry students. I'm going to work out another limiting reactant problem for you here. And I will say before I get started that there are other ways to find the limiting reactant, and if you want to look those up and do it a different way, that's perfectly fine, as long as you show me plenty of work so I can figure out what you're doing. There's at least 3 different ways to do it, and I'm showing you the one that I think works the best. But if you want to do it a different way, again, just show your work and I can figure it out when you're doing chemistry correctly, I promise. Okay, so here we go. Let's start off with identifying some knowns and unknowns and stuff. So we want to know the mass of each product, so grams of each product. Sounds like a lot of work already. Okay, so we've got Alright, so here we go. Let's see, so we know 3 grams of hydrochloric acid. And we also know 3 grams of magnesium hydroxide. Both of which are reactants. So it is up to you at this point to be a chemistry student and realize that, hey, when I'm given the amounts of both reactants, that tells me that this is a limiting reactant problem. So the first step in our plan is going to be to find the limiting reactant. And then after we find the limiting reactant, we'll solve for product masses. Alright, so hopefully somewhere in here, to find the limiting reactant, we're going to need a reaction so we can do stoichiometry with this thing. So I could have included that in the plan too, but anyways, let's write that out. So HCl plus magnesium hydroxide yields water, always a product of an acid-base reaction, at least one that has hydrogen and hydroxide in it. And magnesium chloride, MgCl2. Alright, there would be some balancing here that we need to do, so let's give that a try. So I think if I throw a 2 there and a 2 there, I think that fixes everything that needs to be fixed. And now we're on to finding the limiting reactant, so let's do that now. Alright, so I'm just going to, you can pick either one of these, but I'm going to start with the hydrochloric acid. And I'm going to convert to the other reactant and see how much of the other reactant I would need to go with the 3 grams of hydrochloric acid. So let's add up the molar mass of hydrochloric acid. Alright, so there's 36.458 grams of hydrochloric acid and 1 mole of hydrochloric acid. Then we're going to do the mole ratio from the balanced chemical equation. So there's 2 moles of HCl for every 1 mole of magnesium hydroxide from the chemical reaction. So we'll do that and then get 2 grams of magnesium hydroxide. Alright, so I got 1 mole of magnesium hydroxide is about 58.326 grams. I'm going to plug all this in, multiply everything on the top, multiply everything on the bottom, do the top divided by the bottom. When I carry that calculation out, I got about 2.40 grams of magnesium hydroxide. Alright, so it's time for us to do a little bit of thinking here. So what this is saying is that to react with the hydrochloric acid, the 3 grams that we were given, we would need 2.4 grams of magnesium hydroxide. Well, we have 3 grams of magnesium hydroxide. That means that we have Okay, we're given extra magnesium hydroxide, so that means that HCl is the limiting reactant, and MgOH2 is the excess reactant. The limiting reactant is the most important. Now, once we have that information in hand, what we have to do remaining is to actually solve for the two products. So we're going to solve for the amount of water and for the amount of magnesium chloride. So let's box that in so we know that that's important. And then we'll move right along to solving for the stuff. Now, at this point, it doesn't matter that you know how much magnesium hydroxide there is because it's in excess. So you're not going to use all that. You are going to use all of the hydrochloric acid, so all of our calculations will stem from the amount of hydrochloric acid. So let's set these up. All right, I'm going to do one of these to solve for water and the other one to solve for magnesium chloride. The start will be the same for both because we're still going to go to moles. Alright, so we're going to get 2 moles of HCl. Then the stoichiometry here is going to be, at least the first half is going to be the same, the 2 moles of HCl. And the balanced chemical equation tells us that we make 2 moles of water from 2 moles of HCl and 1 mole of magnesium chloride from 2 moles of HCl. All right, and then our last step, they want us to find the mass of everything that's produced. So we'll have to do our molar masses here. Water is 1 mole. By the way, that number doesn't have to match that. The only place you're going to have numbers other than 1 is on the mole-to-mole conversions. All these other ones, when you're doing molar mass, it's always 1 mole. All right, 1 mole of water. Memory serves correctly, I believe that is 18.016 grams of water. And magnesium chloride, it's 95 point something. Let's add it up. All right, I got 95.21 when I added it up. So that's 1 mole. Alright, and I will go through and carry out both of these calculations again, multiply everything on the top, multiply everything on the bottom, do the top divided by the bottom. Alright, so I got 1.48 grams of water for the first one, and I got 3.92 grams of HCl for the second one here. Now, something interesting you could do here is you could add up those two quantities, and if you added those two together, you would get 5.40 grams. Now here's an interesting thought. We reacted 3 grams of HCl with 2.4 grams of magnesium hydroxide. That would be about 5.40 as well. So that's a way to verify that you did the right thing here, that you added those up, and you followed the law of conservation of mass. Most problems aren't going to ask you to solve for both products, but this one did. So there you go. And another way to check yourself is if you got over 6, you did something wrong. Or if you got a whole lot less than that here, that might be an issue too. So there you go. Thanks for watching, and I hope you found that helpful in learning chemistry.